Итак, давайте перейдем к докладу Дмитрия
So
Евдокимова.
let us proceed with the report by Dmitry
Runtime в
Evdokimov,
Kubernetes для безопасности. Founder, STO,
founder, STO, researchers.
разрабатывает решения по кейсу.
For more than 10 years, he is developing the key security solutions, doesn't believe that the system can become reliable and secure without understanding it. Author of Telegram channel on Kubernetes, Key Securities, Cloud Native courses author. Classical containers are not insulated in terms of security.
Но решит ли все это проблемы и не добавит?
Will it all solve our problems and whether it is going to add more new problems? So let us welcome.
Да, всем привет. Рад всех.
Hi everyone. I'm glad to see everyone. And now we are going to deep dive into the world of Kubernetes and the world of containers to see what can be done in terms of security. And probably for many, it is not obvious. My name is Dmitry Evdokimov. I'm a founder and technical director of Luntry company. My company specializes in security of container media and Kubernetes. We are offering security solutions from the development, rollout, and running. Make sure that everything is safe and secure. Let us proceed with the presentation. It would be quite busy, and we'll look at different aspects of runtime in Kubernetes. And following the schedule, you see that it will be a very diverse view of that, and certainly we're going to look at that in terms of how we see that industry, in our clients, pilots, etc., and where you can encounter that, and what may help you to solve your problems as a team which builds a security perimeter, or if you are representatives of the offensive security, how and where you can penetrate in if you are playing for the red team. Why these might be needed? The first important thing is what Linux containers are about. In essence, this is a very simple Linux process with certain limitations and properties that determine what it may see and how much resources it may have. And certainly there is an image of a container itself which contains all the files that is going to operate. So this is our conventional Linux container. The Linux container at the moment can be created by different runtimes. The most popular one is runc. This is a runtime which used to be, and at the moment is still a part of the Docker. It's been singled out in a standalone project. It's written on GOC, but soon other runtimes emerged. They are different in terms of their performance. There is actually Yelki written on Rusty, but under the bonnet they are the same idea. Namespaces, C groups are being made, etc. If we look at the host in Kubernetes cluster or just on your virtual machine where you create classical containers, in the tree of processes you will see using PSOX, you will see what is inside a container. In that case, you may see different file bits, node exporters, and Jinx, and maybe some sensors, application service, etc. So that means that we see everything which is going on there. So there is no magic. This is just ordinary Linux process. At the same time, we have the same situation in the framework of the report that we're going to analyze, the vectors, and that we can do attacking the applications and everything that works in Kubernetes are numerous. But we will look at only one, the escape from cpod to node. Why? It might be interesting for the attackers. The containers are short-lived substances, and it's very difficult to get embedded there. And node is not modified very frequently, and at node you may find different configuration secrets, certificates, and you can get access to all the containers that work on such a node. So we will consider only one vector. The escapes from containers to nodes are numerous, and in 2021 at the conference I had a separate report on that. But today we'll speak about only one of the vectors. These are the escapes through the kernel of the host operational system vulnerabilities. Why? Because when we speak about classical containers, they have such a property that they all share the kernel of the operational system host. And this system queries go through the system kernel, and once there is a vulnerability, through that vulnerability, we can make an escape, emerging at node, getting hold of whatever is stored there. Kernel, as probably you know, identify lots of vulnerabilities, so they're numerous, and if your application is not protected by anything, if the kernel is outdated, then the attacker may escape to the node from the container. Totally other approaches to providing security for classical containers that about MC-comps, OC Linux, using Kubernetes as a security context. You can also use rootless containers. You can take tiny and slim images when there is only an application, nothing else. That means the attacker will not get either shell or any other toolkits in order to make local attacks. And classical containers can be protected using this list of measures that may make it difficult to run external code and to update the kernel of the host operational system. But we will not look at that. We'll look at the last case. For instance, if we get away from the classical containerization in favor of alternative runtimes, where there is no distribution and working with the host kernels. Let's have a look at that. Kubernetes has a special class of runtime class, and this is something that we're going to consider now. If you're not familiar with Kubernetes, this is not prepared out-of-box solution. This is framework constructor, and every company may use that proceeding from its own limitations and requirements. So this is a giant constructor, and we have not met the same Kubernetes frameworks. They have different interfaces such as CRI, CNI, CSI, CMI, and every platform might be unique. We have a unique configuration, but we would be interested in the runtime container interface, and in essence, within Kubernetes, we don't have one runtime. Kubelet is installed on every node. It talks to the top-level interface, and high-level runtime is responsible for talking to a person. To the orchestrator would upload the images on the node, does the preparation, and the low-level runtime communicates through OCI interface. This is the image itself, and it will run and create that container. And it doesn't know where it gets from, so it prepares only surroundings. In case of a classical containerization, that we about creation of C group, etc. Runtimes, if we turn to CNCF landscape portal, are quite numerous, and you don't see all of them here. You may see how numerous they are, and most of them, as you see, can be used in Kubernetes cluster. Why they can be different, this is what we're going to see now. In terms of application in a Kubernetes cluster, this is enough for us to set that Kubernetes to now such a resource as a runtime class, assign certain name to that, and then following one of the deployments, you indicate the line of specification, and that's it. Nothing else has been required from you, and certain runtime would be used for your container. Within Kubernetes, you may use almost all the runtimes that we are going to see now. There might be 1, 2, 3, 4, 5, and you may change them flexibly. One payload with one runtime, another payload with another runtime, depending on the quality of application situation, with a cluster, etc.
Вообще, за последнее время вот это понятие
Over the last
размылось, и
recently, the notion of container has been diluted. Very often we say that container runtime, these are the things that acquire the OCI format. So it means that we have made an image, and if runtime is there, it's kind of a container. That's it.
недалеко от правды.
As you will see, this is close to be true. Let's proceed with the protection. In terms of ensuring
В рамках
security, there are several aspects to that within Kubernetes, reactive and mitigating measures, detecting and preventive measures. But once we select a standalone runtime, we're interested in isolation of that
системы.
surrounding from the host.
Вообще нет.
How to make sure that it is possible not to touch the kernel of the operation system. This is something that we're going to look at.
Это sandbox.
Let's start with number one. These are the inbox and application core node.
Проект от компании Google как GVisa.
Google
Он называется
offers GVisor application kernel for container, and it has its own low-level runtime, which is called runsc. And in essence, what Google did,
все системные
understanding that all the
хостовой операционной системы
system queries,
системных вызовов, да, взяв за базу ядро 4.4,
we take the 4.4 base, they translated that into the user components, and
порядка 5-7 вызовов,
there is a limited
хостовое ядро. Тем самым, если атакует
set of queries. If the attackers try to
хостовой операционной системы, да,
exploit
скорее всего, будет
the vulnerabilities in the kernel system, most likely it would be run in user space.
7 системных вызовов.
And they have to find the vulnerabilities in those 4 or 5 system
Вот сам по себе рантайм написан
calls
за, в принципе, время существования каких-то критичных уязвимостей
and call requests.
не находилось, что, конечно, же здорово. Как он это делает? У него есть несколько
How it does it? It has several mechanisms under the bonnet, something that you can select, make certain configuration, and it would work on the basis of C-strap, KVM,
у них уходит,
and
и ему вот как раз
C-strap now is becoming outdated. It has been replaced with C-strap. And this is something that I can use. The only thing, we get some limitation that in order to use the fastest approach, you have to use KVM. But for that,
иметь full virtualization,
you will either have a full virtualization or embedded nest virtualization. If your infrastructure lives on the virtual machines, you will be able to use KVM only if the embedded virtualization is
в рамках виртуалок
done.
можно виртуализацию не
But I don't think that any company has anything like that within VM.
по скорости
Therefore, C-strap might be used, but in terms of the productivity and performance, they are losing to KVM and to native containers based on
вот.
runc, for instance.
На ноду, да, где у нас
If you
runtime
go to node where runtime with GVisor
внутри
is working, you will not understand what is going on there. You will see such a process tree,
работает ли там какой-то
and you will not understand whether Nginx, Apache, Goico proxy, or anything like that is run.
сами не зайдете внутрь
Or just 15 miners.
непонятно.
Unless you go inside that container, you will not understand what is going on there. This is a standard picture,
Но
something you have to bear in mind. The developers themselves, in their security in-depth
нахождение
file, describe that there might be some vulnerability within GVisor, which may result in container escape, but at the moment I don't know
баг в нем, который бы это
any bugs that would be identified there.
особенности самого GVisa
Out of interesting peculiarities of GVisor,
выделяют две.
in terms of security, there might be two.
Использовать checkpoint
First of all,
restore,
the use of checkpoint and restore, but it doesn't work in Kubernetes. It works either with Docker or if you create container directly
runsc.
using the runsc runtime. What it helps to do?
Так,
It helps to create
да, делать снимок контейнера,
checkpoints, make an image of the container, and then
ноду, там же его
it may be transferred to another node and then would be run from that status. This is like a career process
должен позволять
that in future should allow us to make live migration for containers.
вы можете для
In terms of security,
контейнера
for forensic, make an image of the container,
команды, они
give it to your SLC team, and from the same place they would deploy to see what the criminals did, or maybe there is some malicious code and it would be totally inaccessible for the attackers. who are within that container. And the second interesting thing that emerged quite recently, gvisor now enables monitoring. And now, through certain configuration, you may say, give me information about certain system calls, for instance, launches of all the exe files or network connections, and it is going to download that into a special log, and we'll understand what is inside that container based on gvisor. So this is a must-have thing if you do an infrastructure on gvisor. But the most important question which is there, this is about compatibility with your applications, as I said. And they took 4.4 as a base. If the application is using some new system calls, the system would collapse. Not all the applications will be run from there. You have to be quite cautious. You have to do a lot of tests with good coverage, certainly, etc. From my experience, what we see in the company, I must say that over the last 4 years of work, we met gvisor only a couple of times. Once it was in the company with a big load, and they work a lot with graphics, with pictures and video. And they do that by means of FFmpeg, and they did a special farm with several dozens of nodes. But the rest of the business load is done in native containers. This is not the most widespread case, and they live on bare metal. They don't have virtual machines, and therefore they use KVM for normal good performance. Micro VM. Such essences might be created. This is not just a sandbox or classical container, but this is a real thing based on hypervisor. We get the host kernel there as well. Therefore, the system calls do not go anyhow to the kernel of the host operating system. The most popular project there is Kata containers, and this is something that we're going to consider in order to do its job. The whole guest operating system emerges, and they offer that to you, but you can do that on your own. There is a Kata agent, and with that, within every micro VM, the command would be set, and you would run such utility as kubectl. Hypervisors are supported en masse. Most of them I do not know. I just met only two. One, the schema, probably you know what schema is about, and Firecracker. This was developed by Amazon company. And for instance, they're using such services, ABS Fargate, ABS Lambda. So it means that it is about a very fast start, minimum retention time, but usually it has been done for some specific functions. If you want to launch an application there, the chances are high that it won't run. And there is a comparative picture which recommends to shows to what hypervisor is worth selecting, bear in mind what load you expect. CAM may launch, may run whatever you want, but you know that its speed is leaving much to be desired. If we look at the same clusters now and try to see how the process tree looks like when this micro VM works, we'll see such a tree, and what is going on in is not visible, is not clear, whether engines, Apache Envoy are working there, or someone has already deployed its tagging tools in maps, etc., trying to scan the network to tag something. We're doing other malicious actions. We do not see that. Every micro VM has to have some agent that you see in big infrastructures. When there are thousands of containers and for every process, you have to do something else. This is very resource intensive and no one can afford it. In terms of threats modeling, just like in every virtual machine based on hypervisor, there is nothing new. In 2020, for instance, at the conference of Black Hat USA, there was a special report on Kata, and the attackers showed how to escape from Kata containers, and they needed a chain made of 2 or 3 exploits. One of the exploits helped to escape from container to the guest operating system, and then from guest operating system they would escape to the host operating system. So even from such a micro VM, there are chances for the criminals to escape to node. But you will see that it will not be done through some vulnerable system calls that go to the kernel of the host operating system. Out of the peculiarities that I would like to highlight, there is always builder tool, which helps you to make your own kernel, a minimum one, and rootfs. That means that you can put whatever you need for your applications. For instance, you want to embed an agent, you may do that immediately. It might be an antiviral software or EDR, whatever you like, you can embed into that. There is another mechanism that I think impacts more the IT component. This is VM templating, which ensures the quick launch of the VMs in terms of the speed. It loses to the native containers based on runC. What main conclusions we can make in terms of Kata? There are lots of restrictions. How the commands are being performed, resources being shared with the host, resource management, setting requests and limits, no production, load, payload is possible without such settings. It's very difficult to do such settings, to scale it up, etc. But at the same time, you understand in hypervisor, there is a requirement to the hardware. It needs embedded virtualization or full virtualization. Most of the companies we were dealing with, they are living on virtual machines. And as I said, embedded virtualization is not there. If we turn to the cloud providers, at least in terms of the Russian providers, I did the research and no one includes such a virtualization. In Western clouds, you can select such a runtime when you make a cluster, but it would incur extra costs because it won't be a virtual machine, but it would be rather hardware. And for me, another important thing is about observability. We don't understand what is going on there. Let me remind you that we are actually considering only one container escape. There are many other ways to escape. So we have fixed one vector and we have not fixed 5 other problems. Another quite important thing, subtopic, that's confidential containers. The very idea there is that you have to protect the data not only during the transferring of data and storage of data, but you can actually protect the data when it is being used. You use the hardware opportunities of the processors, the so-called trusted execution environment, CFV, CGX, and TDDX, and this way actually will identify CPU registers and cache, and only our application and container will have access to that, nothing else. That's quite interesting. It allows us to get protected against the model of a criminal when the attacker has an access to the server hardware, has an access to rack, but would not understand what computation is being done by this or that container, because it would be protected by this T. In terms of confidential containers implementation, so it is connected to Kata containers and cron runtime. In Kubernetes, you may implement as many containers you want. In terms of Kata, all the containers would be run in one virtual machine, and in case of K-run, for every container, they would be its own virtual machine, micro virtual machine. What conclusions we can come up with if in your company you want not to trust even the people who have access to hardware, then you can have a look at this confidential computing. But there is a requirement towards hardware, towards processor, CPU, and I do not know Anyone who would do that on virtual machine, the confidential computing image would be different from the classical one. It gets signatures, it gets certificates, because even when we are launching such an image, the system has to make sure that this is not a modified, that this is a legitimate image. It does server attestation approval, certificate management has to be there, and you have to make your infrastructure prepared for that. Certainly, there are certain tools which would move from classical OC containers to the confidential containers, workload containers, but you will have to take certain actions to do that. And again, there is a question of observability. These are the closed black boxes. You do not know what is going to happen there, whether there is a payload which has been changed or not a payload which has been changed. If you follow the news, then first, most of interest to GX technology. Instructions was raised with the malicious code developers because they were using the black box in order to attack the antiviral software. Quite recently, there was a notion of Windows containers that emerged, and malware developers used that in order to bypass the security tools. I don't know how Windows containers can be used legitimately. I know only how it can be used in order to bypass EDR and containers. The third case in terms of runtime, this is about WASM. If you don't know what WASM is about, it originates from browser. Stored as a kind of binary instructions with a stack virtual machine, and the code is written on any programming languages. And therefore, you can make your own bytecode, and then you result in a runtime which will run that code on any architecture, on any operating system, which will help you to ensure that the code might be imported anywhere you want. Initially, it was a browser type, and then an idea emerged to launch that application outside the browser. A lot of WASM runtimes emerged, such as WASM Edge, WASM Time, WASMer, and if you try to list the WASM runtimes, there are more than 30 of them. They're different in terms of the advancement, their status, they have their own features, peculiarities. There are different compilers of that bytecode, and therefore some bytecodes from different compilers will fit every runtime. And as I said before, WASM or WASM was created for browsers. It was not implied as a standalone code for a host operating system. To make sure that it could be done, the so-called WASI, or WebAssembly System Standard Interface, was developed in order to work with the file system of the host. A network subsystem, unfortunately, it is not stable. It is still in some preview status, and every runtime can differ in terms of how it works with some extensions might be used, such as WACI-X, in order to ensure the synchronization and work with the network, which is not out of box, and the work with the file system, which is not there out of box. So, frankly speaking, this is a very unreliable system. If we look at that runtime in terms of Kubernetes, how to launch Kubernetes code. There are many ways you can do that. We are most interested in the second option, when our application is just run in a virtual machine of WASM. And for instance, you have to bear in mind that the whole part would run WASM code. Those who are servicing the infrastructure now, that there might be several containers within the code, and for instance, if you use Smash networks such as Linkerd, unit containers were to manage security, use the solution.
Там тоже init
Like
контейнер.
Vault, there is an init container inside K container, and you understand that they are not based on WASM. You will not be able to run the
WebAssembly. Есть
payload.
подходы, когда мы
There are other
часть
approaches
контейнеров только аннотируем,
when
будут запускаться.
only part of containers would be native and they would be run by means of WASM. And item 4, there is a special image
Run-C запускается
which would be run in runC and would run this runtime, and this runtime would get this set of bytecodes.
этих возможных.
So bear in mind those potential implementations. The criminals may act differently. Let's highlight the second approach. If we look at that,
Структура у нас
that's a very compact size system. We have DSHIM,
по сути виртуальную машину.
and in essence, it would run that virtual machine
И больше ничего.
where it has only our bytecode and nothing else.
Как бы на передний план выходит вот это.
So here in the front, we have this story about the capability-based security with the maximum,
Изоляции.
how to put it, maximum isolation of everything, because
Ничего лишнего.
only your code gets to the
Возможность сделать
bytecode, nothing else is there.
там шеллы в контейнерах.
Well, local attacks, shells are absent from the containers, which is great. And it reminds me about collecting some static linked app, and if you put it on the scratch-based image where there is nothing there. But if the attacker will have an RC,
Не залить, ему
you won't be able
слить, ему
to upload anything, you won't be able to download anything, you won't be able to create a shell, use any utility, and your virtual code is running in your
тогда фиксить.
WASI virtual machine. And basically, you can fantasize that you won't be needed to fix any bugs.
Немного студить такой пыл.
Anyway, but you should go easy on that because there are different types of bugs, architectural, business-specific bugs, logical bugs. You will have to fix these. But those bugs that are about the development of the attack can be easily eliminated.
Мысли можно сказать о
So here are some ideas about WASM.
лидирующего рантайма, который сказать, вот он там
As far as the leading runtime is concerned, that it will be a leader.
технологиями контейнера.
Roughly speaking, when the container technologies battle was won by Docker, although Google came up with some solutions and other companies, well, we obviously don't see the leader here. There are plenty of solutions, there are interesting ones, but you don't really know which one to choose. So the idea is that WASM code
Не в браузере требуется поддержка
to be launched on host, not in the browser. The web system interface is required, but it's very slow, it's very raw, and the developers are only working on it. The community of them is still growing, and we don't really know what they are going to end up with. There's a lot of problems with the debugging of this bytecode. If your debuggers are familiar with how to do it with Go and Java, but with the WebAssembly code, it's much more seldom, it's less popular, and it's more complicated.
весь под
Like I gave you an example, if we take all of the code run on WASM, we'll take all of the containers, but the patterns in the microservice architecture say that sometimes within the code you will have to use a few containers, and these containers may be written by different developers in different programming languages. You will have to put them into the same view in WebAssembly, although the Vault that we can see that is used in 99% of the companies
решать. Поэтому
will somehow resolve this problem.
вопрос, опять же, обсервабильность.
So this is tricky.
Приложение,
What about
код, отдельное.
observability?
Непонятно, как.
It's different,
В принципе,
and it's difficult. We don't know how to observe it.
что это
There is huge potential for isolation and security. People say that something which could not be done by Java should be done by WASM, and some people say that WASM containers will replace Docker containers in the future. If they will brush it all up, maybe in the n number of years it will also turn out to be the truth, but so far it's not clear what we're going to end up with. Huge potential, excellent isolation, good features, but in terms of the development, there are plenty of difficulties. yet. And here, with a lot of interest to different runtimes, the Kubernetes community came up with this idea of dedicated sandbox API. It's not just have different integrations in different ways, but instead we just identify sandbox API and sandbox plugins. So through the uniform solution, like Quasar, we'll be able to manage all that. Sometimes we use native containers. Somewhere we use sandboxes based on JVisor. Somewhere we use micro VMs or WebAssembly code, and it allows us to do that. Quasar has been toyed by us. We played with it somehow. We wanted to launch this application with this runtime. Let's do it. If there's a critical vulnerability that we can't patch at the moment, and it will take 5 hours to work on, okay, let's just relaunch it. It will slowly move to a different runtime with stricter isolation. After the patch is released, it is patched, and we return it to a proper performance box. So this is a good idea to standardize everything, make everything unified, and to lower the entry threshold. But currently, it's all in a very raw state, and Quasar is the only project to follow here. But if you would like to toy with all these things, put it in the Kubernetes cluster, and you'll check the WASMs and boxes running there. Okay, making a summary out of what I've said, please have a clear understanding of the difference between classic containers based upon the C group and the M space. You need to be aware of the sandbox limitations based on JVisor. It's not the only one. There's also QArch. It's a different sandbox, and micro VMs. They all have their own advantages and disadvantages. Our company's experience proves that classic containers are 99.9% of what we see as clients. If somebody uses micro VMs and sandboxes, it's all about some dedicated specific load in a cluster, but not in the entire infrastructure. And the Western cloud providers offer the following solutions that you could see on the slide. In terms of security, the following things need to be taken into account. First of all, if you would like to protect the native containers, there are ways to do that. There are embedded Kubernetes tools. By shutting down all of the capabilities, by shutting them off, you'll be able to reduce the footprint of the attack. But if it's on the distroless image by Google, if it lies on chain guard image, to make a run, they would have to launch their exploit. They will have to download and run their exploit. If there is nothing in there, they won't be able to run anything. They won't be able to download anything. So it's not rocket science. Make sure that somebody else's third-party code does not run on your system. So this policy can be stipulated in just one single line. Only such and such executive file can be executed here. Or, for example, in a homemade operating system, you can strictly stipulate only such and such executive file can be launched here, can be run here. Otherwise, and therefore they won't be able to launch any other files and exploit the kernel vulnerability. That's number one. The second thing is about isolation. In the presentation, when I started, I said that we will just consider just one vector of escape vector, and there are approximately 6. If the attacker will get to the system, they won't be able to run away through the kernel. They will be addressing the other 6. But you have the problem with observability. You won't be able to see what's download it, what else? Maybe it is scanning the network or scanning the microservice which is nearby, attacking the nearby infrastructure. If it's in the cloud, they will be attacking the nearby services. So this high isolation protects you just from one vector. Are you ready to do that? Are you ready to make such a sacrifice for other ones? It's up for you to decide. And there are very strict requirements for hardware. If you have good hardware, if you have nested virtualization, it's good. If it's not provided, then I think this is not your story. So these isolation mechanisms are based upon other technologies and they have their own limitations. So basically it brings us to the conclusion that there are limitations to the apps to be run there. If they need a host pass, I mean this app does something with a host, it won't be able to operate sharing with the resources with the host operating system. So a lot of these implementations that I've shown, at least today, are very raw, and it's interesting to follow them, it's interesting to play with them in lab, it's interesting to give them interesting experimental tasks, but if you're talking about the rollout of such and such solutions in your company, it would be too early to speak about. So I think I'm done with that. I would like to show you a list of interesting links. Sometimes I use somebody else's research. So for you to have a clearer picture, if something is not clear from my presentation, I would like to show you three more works, and you'll have a brighter picture. I'm done. Thank you very much. I hope it was interesting, and obviously you'll be able to learn something for security. Or maybe you will avoid some bad decisions when planning the security of your container infrastructure. Thank you very much. I'm open for questions.
Да, не забывайте задавать вопросы через нашего бота, а также...
Please don't forget to use our bot to ask questions. Please evaluate the presentation and the speaker. So here are questions from Gurban Valiyev. Which instrument do you recommend to maintain the security of clusters and containers? Followed by, what's your top 3 tools? Well, of course, it's not about my presentation as such. It's a standalone topic. It's a big one. I wouldn't want to recommend anything. At first, I would like you to recommend to take a look at the footprint of the attack, because there are different attacks, and there are some closed containers. Sometimes they're internet-faced. So depending on this threat model, you'll be able to get the priorities right. Sometimes you need the control of the inbound, incoming network traffic. Sometimes network policy becomes more important, or the back controller, which I like actually. So it depends on the task. As far as the top 3 solutions, I think these are not just tools, as you put it. You just need to monitor all of the you may want to use police engine, you may want to control back, so fewer privileges, that's important. Number 3, it's the control of the networking interaction, the use of network policy. So zero trust approach may be very useful here. Even if there is some bug, if there is some vulnerability, they won't be able just to address the service OB. I'm talking about the attacker. And the must-have is just come up with slim images so that they don't contain anything useful for the attacker. Question from Arthur. How can you trust the KSP? Is KSP trustworthy. I don't really understand what the person means here with this acronym. It's difficult to understand the acronym. Yuri is asking, thank you, which containers are most popular for the attack? Which containers are most frequently attacked? It's hard to say. This statistics is not shared. People wouldn't want to disclose incidents. But I think the containers are actually, the environments, the engines, the Python-based.
Попадают в это окружение и дальше пытаются
solutions are penetrating the system and do some damage. But then it depends on how it's all tuned, what they can do, what rights they have, whether they will be able to create a malicious code with their containers, whether they'll come up with a miner. I've never seen miners running in containers, but something like that. Another question from Arthur: is there a quality threat model for Kubernetes? Unfortunately not. Kubernetes is a framework, it's not a box solution, and everyone prepares this taking into account their own needs. We haven't seen two similar Kubernetes. We prepare these projects, we prepare them for the client just to understand what is happening there. A separate story is the email cluster. It's a separate world, separate projects with Jupyter notebooks, with NVIDIA A100 video cards. Although it's a small one, the price of it will be more than some other giant cluster. So this is it.
От Александра вопрос.
The question from Alexander. Thank you. As far as I see, the JVisor is using the functionality of Linux kernel. Is there a big chance of no vulnerabilities in this project? Because it's happening on the system level, but the containers are on the name level. JVisor has got this C group definition and namespace, but potentially vulnerable system calls lie in the Go code. It crashes sometimes, but we do not breach the kernel. Another question: how do you evaluate attack surface on Kubernetes? We check whether it's a closed cluster or not.
Может, компании вручную ходят там через kubectl, что-то.
They sometimes do it manually. Maybe the company does this like GitOps and does everything through pipelines. Some people have platforms, and it is considered individually. You can fine-tune it in Kubernetes, so you won't have to protect anything, and it's still going to be very hard to break. What are the alternatives from Kubernetes? But if you do it, observability starts suffering. That's what I said. By hitting just one vector, we are losing a lot in terms of observability. It was a warning from me. I met the companies who said, okay, we'll just put all of the infrastructure into micro IVM, and they'd say it's safe and secure, but it's not true. Other famous incidents that are related to the escape from a container, as far as the stories in the wild, nobody has ever announced them, but there are some researches, there are some cases, like the Palo Alto team, they would break the services in Microsoft Azure, and they would attack Microsoft control plane and get access to all of the clients that used that service. They have the paper about that. And of course, first of all, they
Так, давайте посмотрим.
reported this to the vendor.
API,
One question from Ilya, sandbox IP related one. QSR looks like the most universal solution,
и станет ли оно вообще
but
стандартом?
will it ever become a standard, really? And will it worth the resources spent with rootless and distryless?
Вот.
I agree with the person who asked this question.
Решать вам, и я больше...
It's up to you to decide. So I think,
Лучше иметь,
if you ask me,
инфраструктуру.
it's best that you have a fully transparent infrastructure if you understand how it works, rather than just
Я больше за...
use this blind spot approach and blunder.
Работает. Ну,
Security, observability are friends, and the embedded PARM, CComp, security context, network policy, slim images give us isolation, a good one, and sometimes they complicate other escape options as well.
Ответы